who are new to blockchain and Ethereum in particular, if you want to follow along with my session, if you have a laptop with you, you can actually use the Chrome browser and then install something called MetaMask extension for Chrome. So I'll show you how to get Ether. So I'll show you how to buy Ether. All you need to do is take out credit card from your wallet, and let's buy some Ether, right? So if you are able to have the Chrome browser and you install the MetaMask Chrome extension, you can actually get some free Ethers, and then you can actually use that Ether that you have obtained to consume smart contract. So I already have a smart contract deployed onto the Ethereum blockchain, and if you have a laptop you want to follow along, you can actually follow my URL, and then you can actually try your hands on a smart contract. So that's only for people who want to try this out. I know this is a long day, so I'll try to promise you not to show you any code. I'll just tell you jokes. Okay, so okay, before we get started, should you be here? I know this is a long day for a lot of people, and there are a lot of very interesting topics. Should you be here? Now, if you are new to blockchain, and if you have been hearing about blockchain and you don't know what the hell is blockchain, you should stay here. And if you're new to smart contract, you heard of this thing called smart contract, and again, you are not too sure what is a smart contract, you should stay here. Or if you simply just are interested in the future, you should stay here. Or if you just want to listen to my jokes, then you should stay here as well. Else, you should go and grab a beer, okay? So if you are already an expert in blockchain, Ethereum, then probably this session is not too exciting for you. But if you are totally new to this, then I hope that in the next 69 slides that I have, seriously, I got 69 slides, not including my jokes. It's going to be a long session. So I predict that I should only be able to finish at 7:30. So, but anyway. Okay, I think we are almost done. Okay, so a very good evening. My name is Wei-Meng. So I have my own training business, and I am interested in everything. So I do a lot of mobile development, mobile training, iOS, Android, React Native, Xamarin, and more recently I'm into blockchain. And I think blockchain is something that is really, really exciting. So how many of you have actually tried to read up blockchain on your own? Okay, how about the rest? You're just not interested in the future? Okay, now, the thing about blockchain is that if you were to actually go and research about blockchain, the problem is there are so many different tools available, so many acronyms, so many terminologies. And so it is always a big challenge to actually learn blockchain. So hopefully in the next 60 minutes, I would be able to give you a good idea behind the thinking behind blockchain, why you need to have blockchain, and what is Ethereum, more importantly, what is smart contracts, and how you can actually make use of smart contract to deploy interesting apps. I'm going to give you some case studies, some ideas on how to actually use blockchain to make money, okay? So I just mentioned, should you be here? I think since nobody leaves this room, then you should be okay. Now, the agenda for the next 60 minutes, I want to talk about the foundation behind cryptocurrencies, and that is the main topic of this talk, blockchain. So you would be able to understand what is blockchain after about 20 minutes into the presentation, hopefully. And I'll explain to you how blockchain works and what are smart contracts. A lot of people are always talking about decentralized apps, smart contracts, so on and so forth. So what are they? So how can you write your smart contract? Good news, there is a new language for you to learn. You guys love learning new programming language, right? Job security, okay? So I will talk about what is a smart contract. I'll show you a very simple example of a smart contract and how you can actually consume a smart contract. And like I mentioned, the new language for you to learn is Solidity, okay? So now, not to worry. This language is very heavily inspired by a language that you guys love and hate, JavaScript. So if you are familiar with JavaScript, you will feel right at home. And I'll show you how to test and deploy your contracts. Okay, now, like I mentioned earlier, if you want to follow along, you can actually use the Chrome browser, install the MetaMask extension for Chrome, and then I'll show you some demos that we can go through together. So now, any presentation on blockchain would have to touch a little bit about Bitcoin. So just in case you are wondering, what is Bitcoin? Why are so many people so excited with Bitcoin? We have to have two slides to explain to you what is Bitcoin. Now, first of all, how many of you own Bitcoin? Bad news. You know the price, right? You know the price of Bitcoin, right? How about Ether? Litecoin. Okay. How many of you actually buy tokens? Okay, only one. And what's the most popular token around nowadays? There's one token on the internet called totally useless token. Seriously. Okay, so now before we talk about Bitcoin, fiat currency. So everybody has got this. So your coins, your dollar notes in your pocket, all these are known as fiat currency. So all these are issued by the government of your country. So you have US dollars, you have the Norwegian kroners, you have Japanese yen, so on and so forth. And you can use them to consume goods and services, right? So what about Bitcoin? Now, Bitcoin is just like the currency that you have in your wallet. So, but it is known as a cryptocurrency. Now, the main difference between Bitcoin and your usual currency that you have in your pocket is that Bitcoins do not exist physically. They exist as numbers on computers scattered all over the world. It is very much like your salary. Now, every month when you get a salary, I'm sure your boss doesn't ask you to go to his office and hand you one stack of cash, right? So basically, they deposit your salary into your bank account. So the key difference between Bitcoin and the currency that you have is, in your fiat currency, your balance of your bank account is maintained by a central body, which is the bank. Now, in the case of Bitcoin, the balance of your Bitcoin is actually held by all the various computers scattered around the world. And each computer, what we call nodes, each node would contain the detailed transaction information about your Bitcoin. So we'll talk about that as we go along. So to pay for goods and services, you can actually use Bitcoin. That was the original design idea behind Bitcoin, to replace the currencies that you have. But I'm sure you have heard of a lot of other stories. Many years ago, somebody used Bitcoin to pay for a cup of coffee. And then they regretted 2 years later. Because the cup of coffee that you paid using your Bitcoin, today you could use it to buy a Tesla or maybe a Ferrari. Okay? So the price of Bitcoin has been fluctuating really, really crazily, like roller coaster ride. So today, the irony is that nobody actually used Bitcoin for paying goods and services. And most people treat this as not an investment tool, but a speculation tool. Okay? So now, and no government owns it. So if you ever lose your Bitcoin, please don't call the police. The police has got no idea what is Bitcoin. Now, the circulation of Bitcoin is limited to 21 million coins, unlike some fiat currency where if the government likes it, the government can keep on printing notes and again, right? So now, why is Bitcoin important? Bitcoin is powered by a technology known as blockchain, and that is the main thing that we want to discuss in this session. So before we talk about cryptocurrency, let's talk about motivations behind that. Now, we have to discuss something that is fundamental, trust issue that we have today. Now, today, any assets of value, they are recorded by a third party, a central body. So, for example, the bank account, the banks has got the amount of money that you have. It holds the balance of your account. And then the government owns the properties, the listing of properties that you have. Somebody would have a record of all your properties. So we trust banks won't steal our money, and they are regulated by the government. And even if the banks fail, it is backed up by the government. So we also trust credit card companies. right? So as a seller, you trust that credit card companies will pay you the money. And as a buyer, you trust that the credit card companies would protect your interests in case of any dispute. So the key thing is the placement of trust is on a central body. So we trust our government, we trust our banks, we trust a central body. For example, if you go to the library to borrow a book, you are trusting, you are placing your trust on the library to maintain a proper record of who actually borrows which book. Okay? So that's the key thing. So the key theme is that we trust institutions, but we don't trust each other. So here's one very good example. So let's say you run a cafe. You're trying to sell coffee, right? So somebody comes in and buy 2 cups of coffee, and they hand you the first piece of paper, the $10 US dollars, okay? And versus the second one, if I were to write my name and I say that I owe you $10, which one would you trust? Before you answer that question, think very carefully. If you say that you don't trust the second one, that's the end of this session. Because what's the point of me talking when you don't trust me? So which one would you trust? Second. Really? Do you sell any items that I can buy using? So you get a point? So you trust that this first piece of paper is backed up by the US government and that you can use this piece of paper to buy something else of equivalent value. And who am I to actually tell you that I owe you $10? Okay? But of course, I know some of you would trust me. So now, what about this case? Look very carefully. Now, assuming that now you are providing some goods and services, and somebody comes up to you and say, hey, I'm going to pay you using, what currency is that, the first one? Venezuela. How about the $100 trillion? Okay? Now, the thing is that, well, you may accept the currency, but the thing is that if you hold on to that piece of paper, the value of this piece of paper would fluctuate really, really wildly. Maybe tomorrow, this piece of paper is no longer valuable. I heard in places like Venezuela, in order to go for a haircut, you have to bring 2 bags of cash in order to have a haircut. Can you imagine that? So can you see the point? So again, back to trust issues. So many years ago, there's one particular bank in the US that collapsed. What bank was that? Something Brothers. Lehman Brothers, right? So banks from established economies, they can collapse. But how about people in less developed countries? How do they trust their banks and their governments, right? So even if the banks can be trusted, your deposits may be monitored by the banks or the government. So the government may be monitoring your account and say, hey, why is it that suddenly you have $1 million in your account? Something must be wrong, right? So you don't trust the bank. And so what do? You go to the Swiss bank. Anyway. What about libraries? What about libraries? You know, this may sound really ridiculous to you, but in some countries, the government may monitor the kind of books that you borrow. For example, what happens if you borrow a book that is titled, How to Overthrow a Dictatorship? You see the point? So cryptocurrencies offer significant potential when people don't trust institutions. So how do we solve this trust issue? Since we cannot trust a central body, so let's trust nobody. So that's the idea behind decentralization. Let's trust nobody. So a very easy way to understand decentralization is this example. So imagine you have 3 persons here, A, B, and C, and they have each a bunch of DVDs. I have to apologize that this example is a little bit outdated because nowadays nobody watches DVDs, right? Yes? You guys still watch DVDs? Okay, never mind. So let's say you have 3 guys, A, B, and C, and they want to share DVDs. They each have a bunch of DVDs, and they want to share with each other. So obviously, somebody must keep track of the whereabouts of each DVD. So how do you solve that? Well, somebody that is really smart says that, hey, let's appoint one guy to to keep track of the locations of each DVD. So, but then, here's the problem. We are back to centralization. We trust a single person. What happens if this guy cannot be trusted? What happens if this guy cannot be trusted? What happens if B has got a habit of modifying the records, the ledger, and say that, hey, whatever DVD that I borrowed, I will just delete it? Okay? So how do you solve this problem? So a better idea would be to get everybody, since we trust nobody, everybody would maintain a set of records. So whenever somebody borrows a DVD, everybody would update the ledger. Make sense? But there is a problem now. What happens if A and C decided to gang up and say, hey, let's cheat the DVDs from B. So A and C will modify the records together. So in the end, you have another problem. Okay? So how to really solve this problem? The way to solve this problem is to have a bunch of people who are not related, not involved in this DVD sharing scheme to hold the records for you. So all this busybody would hold your records. So whenever somebody borrows the DVD, they would update the record on everybody's ledger. Now, of course, you would think that, hey, what's the motivation, what's the reward for all this busybody? Why do they have to maintain the record for you? So we can pay them what we call transaction fees. So this is essentially the key idea behind blockchain. And all these people who are maintaining the records are known as nodes. And in this case, well, of course, in the real blockchain, full nodes does not have any rewards, but we'll talk about that later on. So we are now ready to talk about this term, blockchain. So blockchain, the other name for blockchain is called distributed ledger. So using the same example of the DVD sharing scheme, whenever somebody borrows a DVD, that is known as a transaction. And all the various transactions, they are grouped into a block. And as the block fills with transactions, they are linked to another block. And all these blocks are chained cryptographically. And that's why you have this name called blockchain. So far, so good up to this point? Now, so a blockchain can be used for anything. One misconception is that whenever people hear about blockchain, they say, oh, Bitcoin, Ethereum. The truth is, blockchain can be used for anything. And later on, I'm going to give you some ideas on what are the things that you can store on the blockchain. So we are now ready to talk more details about the blockchain. So like I mentioned, in a blockchain, you have a chain of blocks. So in any blockchain, be it the Bitcoin blockchain, the Ethereum blockchain, the first block in the blockchain is known as the Genesis block. And each block contains transactions. And we link them up cryptographically by hashing the content of a block and storing the hash on the next block. So the next diagram should make it easier to understand. Now, of course, I don't think I need to explain to you what is hashing. Okay? So the beauty of hashing is that it is a one-way operation. And if you just simply modify a single character in the original string, you get a totally different hash result. So that's the nice things about hash. So what we do here is we get all the content of a block, we hash it, we save it in the next block. We hash the second block, we save it in the third block. So the idea behind hashing the content of each block is to ensure that if somebody were to modify a particular transaction, it would invalidate all the blocks after that. So one of the fundamental principles behind blockchain is the immutability of the data stored in the blockchain. Meaning, if you store something on the blockchain, it is guaranteed to be not modifiable. It's always there. It's immutable. Now that you have seen how to link them up, we have to talk about something called mining. Now, how many of you actually have a mining rig at home? Oh, one. How about in the office? Why?
No, some people that have some mining rigs.
Under the desk, right?
Or under the bed.
The best place to run a mining rig is in your office. No. If you are a boss of a company, after this session, go back to your office and check the desk of all your employees. Now, so mining. So what is mining? So mining is the process of adding blocks to a blockchain, all right? So now computers on the blockchain that add blocks to the blockchain are known as miner nodes, okay? So, but then how are these blocks added? So let's take a look at this scenario. Now, so for example, in the Bitcoin network, there are many nodes scattered all around the world. We'll talk about how many numbers are there after this. All these computers around the world, some of them are known as mining nodes. The role of a mining node is to help group all the transactions into a block so that a block can be added to the blockchain. So this is what happens when somebody performs a transaction, when there are multiple parties performing transactions. Each of all these transactions are broadcasted to all these mining nodes. And because of network latency, different mining nodes may refer the transactions in different order, different sequence. So the mining node group all these transactions into a block, and when they manage to fill up the block, they will try to take the block and add it to the blockchain. Now, different nodes would get different transactions. And sometimes a particular transaction may be broadcasted, and some mining nodes may decide not to add your transaction to the block. Why? Because they rank your transactions by transaction fees. So if you are cheap and you specify a very low transaction fee, it will take a longer time for your transaction to be mined into a block and added to a blockchain. Okay? Now, there are so many miners out there. So how do you actually determine who gets to add to the blockchain first? So this is how the mining process works. Now, let me show you a diagram first. So if you look at the structure of a block, you have your hash of the previous block, you have transactions. So in order for the blocks to be added to the blockchain at a consistent rate, the blockchain software, for example, your Bitcoin software or your Ethereum software, they will dictate something called the network difficulty target. Depending on how many computers are on the network, they will adjust the network difficulty target. So how does it work? So basically, a mining node takes the hash of the previous block, add all the transactions, and perform a hash. And the resultant hash is used to match against the network difficulty target. For example, at this particular point, the software says that, the Bitcoin software says that, hey, the resultant hash must start with 5 zeros. So it will hash and check. Does the resultant hash start with 5 0? No. Try hashing again. Make sense? But there is one problem. The hash of the previous block and the transactions are all fixed. So no matter how many times you hash, it is always the same. Remember, Einstein said something? If you keep on doing the same thing and expecting different results, you are a genius. No, you are insane. So how do you solve this problem? Easy. We add a number called nonce. Number used once. So this nonce starts with 0. You take the 0, you take the hash of previous block plus the transactions, you hash. Does it match the difficulty level? Nope. Go up, try again, try 1 now. Does it match the network difficulty target? No, try 2. And this is what your mining rig is doing. Now, sometimes when you read articles, they say that, oh, mining rigs are trying to solve very complex mathematical formula. Bullshit. They are just trying to find the correct combination of nonce that gives you the resultant hash that matches the network difficulty level. So in essence, your mining rig is not environmentally friendly. You are you keep on doing something again, something that's totally useless. Well, if you can mine some Bitcoins, it's not useless. So this is how the nonce work, and this is how mining rigs work. So basically, you just run your machine 24/7, you generate a lot of heat, and hopefully by the end of the month, you get 0.something Bitcoins. So now this process of finding the nonce is called proof of work, POW. Now, POW is very similar to unlocking a digital lock. Somebody gives you a digital lock and say, hey, try to crack this number. So when you have the lock and you don't have the digital number, the PIN number, it is really hard for you to crack it. So you have to try all the different combinations. So in this case, 10,000 combinations. But once you verify that, once you find that PIN, it is very easy to verify. Now, likewise, for a mining node, when a mining node has found the nonce, what the mining node does is that it will say, okay, I have found the magical number. Let me broadcast this block with all the transactions plus the nonce, and I broadcast to all the nodes in the world. And I tell them, hey, stop whatever you are doing. Don't waste your time. I have found the nonce. So all the different nodes there would say, oh, okay, since you have found the nonce, let me verify this. I put in a number, I hash, does it match the network difficulty target? Okay, if it matches, okay, I accept defeat. We will allow you to add the block to the blockchain. So this is how it works. Now, mining is dirty. It is resource intensive, right? So you need powerful GPUs, because GPUs are really good at doing hashing. So, and it uses a lot of electricity. What's the best place to do mining? Norway is not the best place to do mining. The office. Besides the office. Siberia? Okay. Do they have cheap electricity? Do they have cold weather? Iceland. Somebody said Iceland. China. China is a good place to, provided the government doesn't come after you. China is a good place. Why? You go and find all those places that they are really, really cold. So you have natural cooling, and the electricity is really, really cheap. Okay? So Norway is not a good place to do mining. Although I'm running a mining rig. Me and Clarence, we are running a mining rig in our hotel now. So I got natural. Anyway, this is how now if you do not want to run your own mining rig, you can actually go online and subscribe to some mining services where you can actually sign up for an account. You pay X amount of dollars every month, and they will promise you a return on investment of how many coins per month. Okay, so this is how a typical farm looks like. So I think this one is in Russia, I believe, but there are many farms scattered all over the world, in the US, in China, in Russia. So it looks nice, right? But behind the scene, it looks like this. Okay? Now, because all these GPUs, they have limited lifespan. So typically, they can only survive, they can only work about 3 to 4 years. And after that 3 to 4 years, you have to throw them away, buy a new batch. And I think because of the prices of Bitcoin has fell in recent months, recent weeks, the prices of GPUs are getting cheaper and cheaper. So if you want to mine Bitcoin or Ether, this is a good time. Okay? But very important thing is, after this session, please do not sell away your house and use the money to buy Bitcoin. Okay? It's dangerous. Now, let's talk about the structure of a blockchain in more details. So now, earlier on, I mentioned that a block contains transactions plus the hash of the previous block. So that was a simplification. So in actual fact, a block contains a block header. And the block header contains the hash of the previous block, timestamp, nonce, difficulty target, plus something called the Merkle root. Now, you do not store the entire list of transactions in the block header. You basically run them through a process, and you derive what we call the Merkle root. So you store the Merkle root on the, or rather in the block header. Okay? Now, so next important thing, how do you actually derive the Merkle root? Very simple. You look at my transactions here. At the bottom, I have flattened out my transactions. And for each transaction, I perform a hash on it. And in the next level, I take these two hashes, combine them, I hash them. And I keep on repeating until I get a single hash, which is what we call the Merkle root. Now, something interesting on this right-hand side, transaction E, because it has got no more partners. So it duplicated itself. You hash, you get HEE. Again, no more partners. Duplicate itself, hash, until you derive the Merkle root. Now, what is the use of storing the Merkle root in the block header? Every time I explain this, people will always say, hey, why don't I just take all the list of transactions, hash it, store that single hash in the block header? Okay? Well, it can be done, but it is not really efficient. Later on, I'll explain that to you. Okay? So, but for now, this is how your Merkle root is derived. Now, before we talk any further, we have to talk about something called full nodes and light nodes. So, if you want to mine Bitcoin, and be a solo miner, you have to run what we call a full node. A full node contains the entire blockchain. Okay? Now, quick question. What is the size of the blockchain at this moment? Bitcoin. What's the size of the Bitcoin blockchain? Give me a number. 6 gigabyte. 6 gigabyte. 60. Okay. Who can do better than that? It's like auction. Give me a number. 100 and 150. You are close. It's about 200. How about Ethereum? How about 60? Okay, one possible answer, 60. How about the rest? 100 gigabyte. Let me tell you the answer. 500 gigabyte. Now, you can run as a full node. Now, if you want to run as a full node, you can do so. You just need to have a computer that you are able to plug into the network, run 24/7. Now, what kind of computer do you need to run as a full node? What kind of computer? Do you need a supercomputer?
Server.
A server? Raspberry Pi. That is correct, Raspberry Pi. As long as you have a SD card that's big enough or external storage that's big enough to accommodate the blockchain, you can do that. Okay? But remember, you read some time ago, some scientists were in Russia trying to use supercomputer to run. Now, there are also something called light node. So light node are like your wallet. Your wallet contains only the block headers. It doesn't synchronize the entire blockchain. Now, having talked about full nodes, how many full nodes are there in the world at this moment? Let's talk about Bitcoin. How many full nodes are there? Let's make a guess. 100? 1,000? 1 million. That's too many. It used to be 11,000, but because of the falling prices of Bitcoin, I think some people lost interest. So now it's 9,879 as of today, this morning. Okay, so we have 9,000, about 10,000 nodes. United States has got the majority, 25%. I cannot find Norway here. Anyway. How about Ethereum? How many full nodes are there for Ethereum? 50,000? Can you see from here? 17,000. 17,000. Okay. Now, what is the reward for running a full node? Why do you want to run a full node? Transaction fees? Good point. No. Full node doesn't earn transaction fees. Full node basically, a full node may not be mining nodes. Mining nodes earn transaction fees. Okay? Full node basically download the entire blockchain, archive the entire blockchain, maintain the entire blockchain. Full node does not make any money. So why would you want to run as a full node? Because you want to contribute to society. No, it's real. You want to contribute to the security and stability of the blockchain. Oh, sounds really good, but anyway. But this is true. This is true. There's no financial reward for running a full node except to make yourself happy.
So who runs the full node?
It can be you, I, or some organization.
No reward whatsoever?
No reward, unless you are a mining node. Okay. Now, how can you run a full node? Easy. You go and Google for this software called Geth, G-E-T-H. It is available for Linux, for Mac OS, for Windows. You just run Geth in your command prompt, leave your machines running for a couple of days, and when you look back at your machine, you will just be 500 gig poorer. Okay? They will download the entire blockchain onto your laptop if you try that on your laptop. Anyway, so we have to move on. Now, the next thing that we want to talk about is what we call confirmation. Now, as more blocks are added to the blockchain, we have something called confirmation. So, for example, in this diagram, block 4 has got one confirmation. So, itself is counted as one confirmation. For block 3, it has got two confirmations because you have block 4 and block 3. So, they have actually worked out the theory that, in general, when a block has got 6 or more confirmation, it is deemed infeasible for it to be reversed, meaning it guarantees that the data that is stored on this blockchain is immutable. You cannot change the content anymore. Unless in the case of Ethereum, you go and wipe out the 17,000 nodes and start all over again. Okay? So, now rewards for miners. Now, in the case of Bitcoin, initially in 2000, now, which year was Bitcoin initially launched? 2009. Okay? I keep on slapping myself. If I would have known the price of Bitcoin is so high today, I would have started in 2009 and started mining. And I wouldn't be standing here right now telling you jokes. In the early days, you could mine a Bitcoin, buy a block within a day, and you get 50 Bitcoin as a reward. How much is Bitcoin worth today? 6,000? 6,000 US dollars? 6 times 50? And you don't have to worry about what is DevOps, React Native, GitHub. Who cares about all this? Okay, back to reality, sorry. Too late. You met me too late. So the reward would halve every 210,000 blocks. So every 210,000 blocks, it will halve the reward. At this moment, is 12.5 Bitcoin. So today, if you mine a single block, you will get 12.5 Bitcoin. But those of you who have mined Bitcoin, they will tell you, dream on. It's not so easy. Okay? So what is the typical ROI? Somebody can tell me, how many Bitcoin can you, how many Bitcoin can you, or how many Bitcoin can you earn per month? Those of you who are running mining rigs, Bitcoin. 0.000. Okay. Now, it will eventually be reduced to 0 after 64 halving events. Okay? Now, when that day happens, the mining nodes would actually basically earn transaction fees. They would no longer earn mining rewards. So for the Bitcoin, The network basically adjusts the difficulty of the puzzle so that a new block is being mined roughly every 10 minutes. Okay? And then for Ethereum, a block is mined approximately every 14 seconds. So there's this discussion. Some time back, people were saying that, okay, in China, the government is cracking down on all this mining farm. So people are worried because they say, oh, there are lesser mining nodes available. Is this good news or bad news to you if you are a miner? It's good news. Because when there are lesser competitors, the network difficulty will adjust so that it becomes a little bit easier for you to mine a block. Okay, so there is a website that's live. So if you click on this, they will tell you that we are 712 days away from the next halving event. Okay, so you still have time to go and buy a mining rig.
What's a halving event?
Okay, halving events means at this moment is 12.5. After 210,000 blocks, they will halve the rewards. So 12.5 divided by 2, and then 6.75 divided by 2. So they'll halve it. This is what I talk about. So Bitcoin blockchain as of May, but it's growing. So it's about 20 gig for Bitcoin, and Ethereum is 500 and something gigabyte. Let's talk about something that is important to most of us, Ethereum. So since we are programmers. So Ethereum is an open blockchain platform, very similar to Bitcoin, except that Bitcoin was primarily designed for cryptocurrency. That means using Bitcoin as a mean to pay for goods and services. Now, Ethereum has got its own fuel, which is called Ether, but the main design philosophy behind Ether is not to use as a cryptocurrency, although most people treat Ether as a cryptocurrency because people want to speculate. So people buy Ether. How much is Ether worth today? I like to ask a question. $600 US. So it's still very cheap compared to Bitcoin. So if you want to buy cryptocurrency, buy Ether. No. Let me take back my words. Don't. Tomorrow, me and Clarence, we will have a session on how to set up your own mining rig. So I will show you how to actually connect your mining rig to your office network. No. I will show you how to set up a mining rig, and we have a mining rig at the hotel. So tomorrow we will bring it to this room, and then if you are interested, you can come and we will show you some tips and tricks. So Ethereum, the main difference between Ethereum and Bitcoin is that Ethereum is a programmable blockchain. It's a programmable blockchain, and it supports a programming platform known as smart contract. So this is not important. Now, let's talk about this. Now, if you want to get connected to the Ethereum network, you can use a software called GEF, which is written using the Go programming language. So GEF is basically what we call an Ethereum client, which allows you to connect to the Ethereum blockchain so that you can actually create accounts, transfer Ethers from one account to another account. You can deploy smart contract. So GEF would also allow you to deploy a test private network within your organization, within your office, so that if you are trying out your smart contracts deployment, you don't have to deploy onto the real Ethereum blockchain. So you can try it within the comfort of your office. So let's talk about smart contract. So a smart contract is basically a program that you write, and you can deploy to all the nodes on the Ethereum network. Now, a good way at this moment to imagine a smart contract is, now, today if you use a language like C#, you write an application, this application runs on a single computer. But a smart contract, again, is very much like your application that you're writing today, except that the application that you have written today, instead of running on one single computer, you take your application, you deploy to all the different nodes on the Ethereum blockchain. So you deploy everything. And when somebody wants to interact with that smart contract, they would actually write an application, maybe using HTML, and using a set of APIs known as web3.js to interact with your smart contract. And when you want to execute this smart contract, your application is actually executed on all the nodes worldwide. And the first one to finish executing, he will actually try to mine the block, and all the other blocks would verify that, hey, this is the correct block, then they will add it to the blockchain. So I think that's the easiest way to understand what is a smart contract. So I'm going to show you some case study. I think that's easier. So you used a language called Solidity, and you compile your contract into what we call bytecode, very similar to Java bytecode. You take your bytecode, you deploy that onto the Ethereum blockchain. And your bytecode, which is your application, gets deployed all over the network. When you want to make use of this contract, you would write a web application, for example, using a set of APIs known as Web3 JS API, and you can actually interact with your smart contract. Why do they call this Web3? Because you have something called Web 2.0. Yes? Who actually came up with this term called Web 2.0? Who actually came up with this word, Web 2.0? Tim O'Reilly. You know the publisher O'Reilly? The one that has got a lot of animals on the book cover, and then you're always wondering why they choose this particular animal. So he came up with this term Web 2.0 to describe web applications that has got intelligence on the back end or on the front end. So when smart contract is being launched, a group of developers, they came up with this API, and they said that, hey, we are now much better than Web 2.0, so let's call it Web 3. They just want to be better. So it's a set of JavaScript APIs, and you can actually use your application to actually talk to your smart contract. Now, I know if you are new to smart contract, this is something that's really, really abstract, but let me give you some ideas. So the first example is copyright. So for example, I'm a music composer, and I compose music, so I have my song's lyrics, and I want to copyright it in such a way that, hey, if a few years down the road somebody came up with another song that has got the same lyrics, I want to be able to prove that, hey, I'm the one who initially has got this song lyrics. So what I can do is that I can actually write a smart contract, and I can deploy it onto the Ethereum blockchain, and I can write a web application. Now, if you want to copyright your songs, you simply put in your lyrics. I will hash it. I'll take the hash, and I'll store it onto the blockchain. And remember, a blockchain is immutable. So whatever things that you have stored onto the blockchain, nobody can change that. So a few years down the road, if somebody says, hey, it has got a song that has got the same lyrics as you, what you can do is that you can take the lyrics and say, put it into the blockchain and say, hey, I can prove to you that this song was initially added to the blockchain on this particular date. So the same applies to enforcing wills. For example, you want to write a will to list out the things that you want to pass down to your children. So you can actually hash that content of the will, store it onto the blockchain, and as long as that 17,000 nodes are still running 20 years down the road, you would be able to prove that this will is the original one. So this is one example. Another example that you can think of is online betting, online gambling. So in my workshop that I've done on Monday and Tuesday, we actually did something on this. So we actually write a smart contract. And I write a smart contract and deploy it onto the Ethereum blockchain. So my application allows people to actually play this game. So in order to play this game, players would make a guess. My game is going to draw a number from 1 to 20, a random number from 1 to 20. And I invite players to actually place a bet a number, and bet X number of ethers. So once I deploy my contract, I will just sit back, lay back, and wait for money to fly in. So when people bet on this program, they send me ethers. They send ethers to this contract, and this contract is automatically written to draw a winning number after X number of players have betted. So at the end of the betting process, I'll draw a number. If there are winners, the winner would share the total amount of money betted. If there are no winners, this pot of Ethers would go back to my account. Can you imagine that? Now today, if you want to do something like this, you still have to invest on your server. You have to apply for AWS, Azure. You still need to host your application, right? But in the case of smart contract, I take my smart contract, I deploy it onto the Ethereum blockchain, I pay for the deployment, that's it, a few cents, and then I can just wait and sit back, wait for the money to roll in after, provided I'm not arrested. Is it legal to do online gambling in Norway? No? Perfect. Okay? Now, so this is a typical smart contract. This is a typical smart contract that allows you to actually store your song's lyrics, to copyright your song's lyrics, and to verify that this lyrics has previously been copyrighted. So if you look at this, I don't think we have time to go through all the syntax, but if you look at this, it's very similar to C#, very similar to your JavaScript. Okay, so let me see whether I can show you a demo. Okay, there you go. Now, for those of you who has got a computer with you, you have Chrome, you have MetaMask extension, you can key in this. If not, you can just take a photo of this. When you go back to your office, you can try that out. But I'm going to show you this. Okay, so first of all, you need Chrome. And you need this piece of software called MetaMask Chrome extension. And something interesting is that this is a fox, and yeah, it's fun. You know, sometimes when you cannot find a bug in a program, you just go to here and say, oh, okay. Okay. Now you can create multiple accounts. So what is MetaMask? MetaMask is basically your Ethereum wallet. It's a piece of software that allows you to keep track of all the accounts that you have and the balance of your Ether. Now, MetaMask allows you to connect to different types of network. If you select the main Ethereum network, you would be able to see that. So this is the rail network. So if you want to deploy a contract onto the main network, you have to pay for this. So obviously, you see that I am as poor as most of you, 0 Ether. But then if you are using this purely for development purposes, debugging purposes, I always like to go to one of the test networks. So I go to Robstan. And initially, when you create a new account, you have 0 balance. So you can buy some free Ethers. So click on Buy. Click on Robstan Test Faucet. You'll see this page, and you can request for some free Ethers. So I'm going to click on this. Click. And fingers crossed. Now, this happens all the time. There you go. So you have a transaction. When you click on transaction, they will bring you to this place called Etherscan, which tells you that, hey, this transaction is now included in the block, and it is in the process of being mined and added to the blockchain. So how much time would it take to get confirmed? Let's see whether you are paying attention. 14 seconds. Okay? But that is in theory. Ethereum. This is Ethereum.
Yeah, but this is your blockchain. This is your implementation.
No. This is one of the testnet. It's available worldwide as well. Okay, so in theory, 14 seconds. Now, you can see that it is still pending. And I can go up to here. There you go. I am now 1 Ether richer. And please don't get too excited when you see this US dollars. This is not exchangeable for real cash. Okay? Now, so if you want more Ether for testing, you can click on this button a few more times. Okay? But be very careful. If you click more than 12 times, you will see an error message at the bottom, a JSON message, user is greedy. Okay? Now, So you wait a while, you will see that you have so you will trickle in. So I should have, how many? 4 ethers. There you go. Okay, so now I am ready to consume my contract. So let's go to here, and let me just copy this. And I'm going to paste this in. Okay, so this is my application that I have written. I have deployed a smart contract onto the Ethereum blockchain, the test blockchain. And I am now going to consume this application. This is a HTML, CSS, JavaScript application using the Web3 API. And I want to copyright a song. Can you suggest some songs? Justin Bieber? No, strictly no Bieber here. Okay, hello, Oslo. Okay, this is lame, right? I know, but anyway. Let me just click on this, copyright. So when I click on this, MetaMask will intercept this and say, okay, you are trying to send a transaction onto the to the smart contract, and you need to pay for this. And this is in the unit of gas. When you deploy something, when you consume a contract, you pay for this using a unit known as gas. And how do you pay for gas? You use Ether. You use Ether, pay for gas, gas pays for your transaction. So gas is a unit that's really important in Ethereum. A gas would actually dictate the complexity of your application. So the more complex your application is, the more gas you need to consume that contract. Okay? So if I say OK, click Submit. So it will submit that transaction. And all I need to do is wait for it. So I see a 3 dots here. It means that it is still pending. All right? So now, in the meantime, let's try to key in something else. Somebody was saying Justin Bieber, right? The last time I tried to key in Justin Bieber, it crashed my computer. But anyway, if I click on Verify, it says false. Okay? It means that in my blockchain, there is no such lyrics called Justin Bieber. Okay, so there you go. Okay. I'm not too sure whether you've seen something earlier on. For those of you who are really fast, you see one line here. So before it was successfully mined, the MetaMask tells you that, hey, if your transaction is taking a long time to mine, try to adjust the gas price. If you try to adjust the gas price, there is a higher chance of your block, or rather your transaction in the block, being mined at a faster rate. Okay? So all the miners are greedy. So when they look at the transactions, they look at the transaction fees. In this case, the gas price. If your gas price is really high, they'll put you as the top priority, and they try to mine your block first. Okay? Now, we managed to copyright this song. Let's copy this, put it inside, and let's try to verify. Click, true. So verify means I take this string that you have here, I hash it, and I verify with that on the blockchain. And let me try to find on the blockchain, is there really such a hash? If there's such a hash, it can prove that, hey, this song, this lyrics was previously copyrighted.
Using the same Web3 API?
Yes, yes. So this is a very simple application that you can actually build. And let me see, I'm left with 4 minutes. So, okay. Let me try to finish off the slides. So Web3 API. So to communicate with an Ethereum node, you would need a set of APIs. And in this case, I'm using the Web3.js API. So behind the scene, the Web3 API talks to an Ethereum node using the JSON RPC calls. So too much details to talk in 1 minute, but just to let you know. Now, for those of you who actually missed the code for this, you can actually go and look for the latest issue of Code magazine. So this Code magazine has got this article that I've written. It basically covers the same topics that I have went through, everything except the jokes. Okay? So you can it's available online, so you can actually go and read the article if you want to. So I'll let you take a photo first. Do you want me to be inside this photo? Yes. No. Okay, I think I got one more. So now, next important thing. If you recall this browser, right? This browser. And when I want to consume this smart contract, when I click on this button, MetaMask pops up. And this is a browser. Now, the common question that people always ask is that works okay. But in the real life, you don't expect me to tell my end user, hey, in order to use this contract, you must go and install MetaMask. And go install MetaMask, and then you have to use Chrome browser. What about mobile devices? Can I consume this web page on my mobile devices? Now, in this particular case, no. Why? Because your mobile browser does not support the MetaMask extension. So how do you actually call a transaction? How do you actually pay for that transaction? So again, a lot of details, but I try to summarize this. Now, behind the scene, MetaMask actually connects to a node called the Infura node. So if you go to infura.io using a browser, you'll be able to actually register an account, run your own node. So now, why is this important? If you are trying to get this web application running on a mobile device, what you need to do is you need to run your own Ethereum client, just like your Geth node, just like your Infura node. And in this case, if you want to run your own Ethereum client, you have to run a piece of software called Geth and modify your application to communicate with your own node. And once you do that, your user would be able to consume your smart contract on their mobile device. Okay? Now, a lot of details. So I used to say this. Learning blockchain is like the 7 blind men touching the elephant. Have you heard of this Indian parable? Have you heard of this? You know, you get 7 blind men, and you ask the 7 blind men, describe to me, how does an elephant look like? So the 7 men would go and touch the different parts of the elephant. Okay? And then they will come back to tell you the different characteristics of the elephant. Some may say, oh, it's thin. Some may say, oh, it's really big. Okay? So when it comes to learning blockchain, depending on where you go, which website you go, which magazine you read, of course, read my article. There are so many different technologies available, and every time people talk about different components of the blockchain. So hopefully, this session has managed to combine all the important things into an easy-to-understand format, so that after this session, you would be inspired to actually investigate smart contracts programming. So this is the next big thing, and hopefully, next year, I would still be here talking about blockchain. If not, don't worry, but I'll talk about something else. Okay, thank you very much. So enjoy your party.